Hey, what's a monolithic architecture versus a microservice architecture? Well, in this video, I'm going to show you how to do it. My name is Ray. And so one of the things I like talking about is the different architectures. And what we're going to talk about is the difference between microservice and a monolithic. Now, when we first start with a monolithic architecture, a lot of times we're doing that when we're trying to prototype something or trying to build something for the first time. And then the microservice architecture is more like we're talking about scale. So monolithic, so we're going to go monolithic versus microservice. Okay. So the way it works here is that when you're on a monolithic system, so when we're talking about software development, we're talking about user interface, we're talking about storage, backend, APIs, stuff like that, databases. And what happens is that you use the resources of that system with your software, right? So in a monolithic system, you basically are going to build a user interface, UI, UX, okay, which is your user interface. You're going to build a backend system, which handles a lot of the logic. You'll have a database, okay? You're also going to have to worry about storage, like you put all your storage on that same box, right? The same server, okay? And so what we're talking about here is we're talking about CPU usage. Okay, we're talking about CPU usage, we're talking about memory usage, we're talking about storage or disk. I'll just use hard disk. It's a lot easier. So hard disk space. I think that's basically it for now. So when you do this, you're building basically all of this within a box, okay? And all of it's within the same box. So like I said, it's all self-contained in one box. Now what happens is if you need to scale the system, you have to scale vertically, which means you have to scale the box itself. So in this situation, the more you need, the more CPU you need, the more memory you need, the more hard drive, you just have to continuously keep building the box bigger in order to be able to handle the amount of load. On a microservice architecture, the reason why this is important is because, well, let's say we take the same situation. I'm going to throw UI UX here, right? I'm going to say our backend system is an API, right? Which is mostly what backend systems are. It's an API, okay? Then we have a database here, okay? And then let's just throw storage over here. Storage, okay. So each of these is going to be self-contained, right? So self-containerized. So we have our UI UX basically built in a separate container. Your backend API, separate container, database in its own, and then storage. And I'm using container as loose. I'm not talking about containerization yet. I'm talking about just, it's its own little box, whether it be an instance, a server, a container, whatever, but it's living on its own. So what this allows us to do is it allows us to add, for instance, a CDN, a content distribution network on the front end of your UI UX, therefore making it faster. Because what happens is it spreads that UI UX across edge servers all across the globe. Therefore, when someone in another state or another part of the country is accessing your user interface, they get the user interface from a server near them rather than having to make the communication all the way back to home base, wherever your main servers and stuff are stored. So then user interface contacts the API. So for scalability, we may have multiple backend, and I'm just going to do this quickly. We may have multiple backend systems in each container. That could be each instance of a server or a containerization model. And then you can throw what's called a load balancer right in the middle. So that's an LB, or in Amazon, we call it an ELB. All right. What this means is that when the UX and UI hits that load balancer, it uses a round robin architecture. To basically go to each server individually, one at a time. So first user goes to first server, second user goes to second server, third person goes to third instance, and then it just rotates back around. And what that does, it allows you to handle a lot more traffic because that load balancer is balancing all that traffic. Similarly, your UI UX may have storage, maybe accessing images, right? Your back end could also be accessing images here, right? So when you have your storage in a whole separate area, it allows you to scale that as well separately. You can have one storage box with, like for instance, Amazon, they have S3s, and Azure has their own. And so same thing for databases. So you have a database here. So your backend communicates to the database, and then it communicates back to your backend. it can communicate to every single one of these backends that have been created individually. What we usually like to do is we like to throw some read-write replicas in order to maintain a good flow on your database, so you're not bogging it down. If a company accesses reports and stuff like that, if they're doing it off the same monolithic server, that means everybody else who's accessing the application is going to slow down, because now they have to wait for the system has to wait for the report to be completed. But when we use a microservice architecture, we can do what's called a read-write replica. So we call it a read-write replica here. So what that does is that anytime anything gets stored in the main database, it saves it to the read-write replica. So what happens is our backend will only make creates and updates, right, to the main database, and then all of them will create reads, what we call a read request, to the read-write replica. So what this does is it shares the amount of load onto two different databases so that you can scale your backend more, and you can actually have more throughput for your data. So there you go. So again, that's the main difference between monolithic and microservice architecture. Now we can go far deeper into microservice architecture, because every time you incorporate an integration with another system, you usually create smaller little applications that'll communicate and integrate with other systems. And that adds to the microservice architecture, because you can split that off from one box, right? Whereas again, if you're monolithic, you're kind of tied to that one box. If you do any integrations, you're building it within that same box. Therefore, it taxes that box. The more enterprise you become, the more taxing it becomes. And that's the reason why microservices has been so popular. Now there's other methodologies of called container-based structures, which uses Kubernetes, which is a technology that allows you to distribute all of your applications and all the parts of your applications to different containers and manage those and all that kind of stuff. And I can have a much deeper conversation about that from a technical perspective. That's just another avenue, but to me, that's sort of very similar to a microservice architecture. You're splitting off the processing and everything to each individual component separately, rather than everyone having to share the same thing. Tell me what you think. If you have any other questions, just put them in the comments.